Hello everyone. Hope you are happy and healthy. Let us begin a new chapter. We will study chapter number 4, carbon and its compounds. Before we begin to learn carbon and its compounds, let us look at the pictures of the things which we use in our daily life and we'll try to find its common component. So let us start with the clothes. The clothes which we wear, it has carbon as one of the components. The plastic bags also have carbon as one of the components. The plastic bottles or containers also have carbon as one of the components. Then the soap which we use in our daily life, that also has carbon as one of the components. Same way, the liquid soap also has a carbon. Then the detergent powder also has carbon. The paper, the writing paper also has carbon. The pencil also has carbon. We all know that it contains graphite, which is the form of a carbon. Then petrol, that also has carbon as one of the components. Then the gas LPG, that also has carbon as one of the components. So from all these examples, we can conclude that the food which we eat, food, then clothes, the medicines, the books, or many of the things which we use in our daily life, all are based on the versatile element which is carbon. It is said that it is a versatile element. Why it is called versatile element? Versatile element means which can be used for different purposes. So here we have seen for this many examples that for carbon is used for so many things. That is why it is called as versatile element. We all know that carbon is an element and it is a non-metal. Here we need to remember that most carbon is poor conductor of electricity. Not all forms of carbon, okay? Please keep it in mind. Most of the carbon is poor conductor of electricity. Also, all living structures are carbon based. The Earth's crust has only 0.02 percentage carbon. Only 0.02 percentage carbon in the form of minerals like carbonates, hydrogen carbonates, coal, and petroleum. And the Earth's atmosphere has 0.03 percentage of carbon dioxide that we all know. So you can think that how much small quantity is of carbon. In spite of this small quantity or small amount of carbon available in nature, the importance of carbon seems to be immense, which means even though it is present in small amount, it has versatile nature. It is used for many different purposes. So in this chapter, we will study about the properties of carbon which make carbon so important to us. Here I want you to recall chapter number 3, in which we learned about ionic compounds. We have also learned the properties of ionic compounds. We learned that the ionic compounds have high melting and boiling points. Also, they conduct electricity in solution or in the molten state. We also have seen that the nature of bonding in ionic compound explains this property. We have learned this example of formation of NaCl, and we saw how the ionic compounds are formed. In this chapter, table number 4.1 is given, which shows melting points and boiling points of some compounds of carbon. Acetic acid, chloroform, ethanol, methane, they all are carbon compounds because they contain carbon. So here we have information of melting points and boiling points. This is table number 4.1. Now I want you to refer table 3.4, which is from chapter number 3, which shows melting and boiling points of some ionic compounds. So here we have ionic compounds like NaCl, LiCl, and many more. Melting points and boiling points are shown. Here, what do you observe from these two tables? I'm sure you can say that the melting points and boiling points of carbon compounds are less than the melting points and boiling points of ionic compounds. From this, we can conclude that the forces of attraction between these carbon compound molecules are not very strong, and that is why they will not require high temperature, that much high temperature, to break that force. On the other hand, when we learned ionic compounds, that time we saw that they have strong attraction force between them, and that is why they need high temperature to break that bond, and that is why their melting points and boiling points are high. Whereas for carbon compound it is different, which means we can say that the molecules do not have very strong bond. One more thing to note here is that these compounds are non-conductors of electricity. Okay, and that is why they will not produce any ions. So this we need to remember. In standard 9, we have learned the combining capacity of different elements and their valence electrons. This we have studied in chapter number 3 also, and also in standard 9. So let us once again revise it. Let us see for carbon element. Carbon has 6 electrons and it will occupy 2 shells. We have learned this in detail in chapter number 3. So you can refer the electronic configuration from that chapter videos. So let us see for carbon. 6 electrons will be occupied in 2 orbits. First is K shell, next is L shell. So we know that in first orbit we can fill maximum 2 electrons. So in first K shell there will be 2 electrons, and in the next there will be 4 electrons. In this way, electronic configuration of carbon is 2, 4. Total 6. Now, when we learned ionic compounds, that time we learned that outermost orbit has valence electrons. So that valence electrons will be given or will be taken to make compound. Okay, if there are one electron, two electron, or three electrons in outermost orbit, then that element will lose electron. If the outermost orbit has 5 electrons, 6 electrons, or 7 electrons, then it will gain electron. We also know that by losing electrons, it forms cation, and by gaining, it forms anion, that is negative ion. What is that for carbon? Because carbon has 4 electrons in its outermost orbit. So if carbon gain 4 electrons, then it forms carbon anion, that is negative ion. 4 electrons it will gain. But if that is so, then it would be difficult for the nucleus with 6 protons to hold on to 10 electrons, that is 4 extra electrons. Do you understand what I am saying? The nucleus of carbon. Okay, already it has 6 protons in it, and this 4 extra electrons it is gaining. In first orbit there are 2 electrons, in next orbit there are 4 electrons. If it is gaining 4 extra electrons, then there will be total how many electrons? 10 electrons. And the protons present inside the nucleus are how many? Only 6. So it will be difficult for this nucleus to hold this extra electrons. Same way, if we take the case that if carbon loses 4 electrons, okay, then by losing 4 electrons it forms cation, positive ion, okay. But what will happen then? It will require large amount of energy to remove these 4 electrons. Why? Because already there are 6 protons present in the nucleus of carbon. Outside the nucleus it has 2 electrons. Then it will need extra energy to remove this 4 electrons. Because in the first orbit only 2 electrons are there, so with that 2 electrons it will be very much difficult to remove that 4 electrons. So this is the problem to attain the octet configuration. So there is a solution to overcome this problem that we'll study now.